Okay. All right. So yesterday we looked at influential versus outlier versus neither, right? So today we're going to look at, we're finishing up here. We only got a few more slides. This is the rest of chapter 3. There's no more other things other notes that I have. And then the last one is just a practice problem. So we have this, and then we have interpreting data, some data, and next week. So next week, we're going to do a little activity in class. We're using all of chapter 3 as a good review. Okay, we'll do that probably Monday and Tuesday. We'll do some review, and then we'll do a group test, like we did for chapter 1. Group test is you're in a group. You take a test, you can work together, you can use notes, and when you're done, you turn it in, and then we'll take the actual test. Okay, so we're coming down to the wire here with chapter 3. So, but I want to finish the new stuff before we do all of that. I want to make sure we've gone over everything in chapter 3 that you're going to be responsible for. So R squared, right? I think someone said, I think you guys are saying, I've seen R squared before. It's on this guy here when we're on the calculator, when we're calculating A and B and R squared is there as well, right? It's one of the 4 things it gives us. The first one is just the equation A plus bx, and then it's the first one is the y-intercept, then the slope, and then R squared. We've always skipped that, right? And gone to R. So first of all, how do you calculate R squared? How do you think you calculate R squared? There you go. You just square R. You guys know how to get R, right? Use the calculator. Well, if I give you R, correlation coefficient, you just square it to the second power. This number right here squared is this number here. That's it. Okay. So if they ask you to calculate R squared, just go find R and square it, or just look here. Okay. So that's how to calculate it. More importantly, though, what does it mean? And it's kind of one of the more interesting things, statistics in this chapter. It's called an effect size. How much effect does it have? Okay, so here it is. Here's the textbook definition: role of R squared. So it's called the coefficient of determination. Like correlation coefficient is R. Well, R squared is the coefficient of determination. That's what the formal name is. But most of the time we just say R squared. The square.
Here's what I found from wikipedia.org.
My phone, my watch was listening to me, which is kind of scary. The square of the correlation coefficient, or R squared, represents the percentage of change in the Y variable that can be, here we go, right here. This is the main part right here. That can be attributed to its relationship with the X variable. So that word right there, the big word in this is attributed. So if something is attributed to something else, what does that mean? What does the word attribute or attributed mean? Perfect. That's it. It's the reason why something's happening. That's what R squared is. R squared will tell you a percentage, and it'll help to explain why the Y is what it is. Okay. So they have some fancy jargon here. It says, so if R squared for the regression between X and Y is 0.73, we can say that X accounts for 73% of the variation. So variation is a word they like to use in there. So anytime, if it's a multiple choice question and they ask you to interpret R squared, there's only going to be one of them that have the word variation. Okay. So if variation is in one of those, it'll always be in one of them, just one of them. That's the answer. Okay. But I don't really teach that definition. I teach a more practical definition. I teach more of what's the last sentence. In other words, the explanatory variable is 73% responsible for the response variable. Okay. So let's go back. I'm going to put some stuff up here. and I'm going to show you some stuff we've done earlier in the chapter where we found R. Where is it? Right here. Do we find R for this guy? I think we did, but earlier. Let's try to find it. We did find R. Okay. So one of the reasons why they square it, or it's called squared, is because if R is negative, it gets rid of the negative, right? So R squared here. So using your calculators for this question here, what would R squared be? Tell me real quick, what would R squared be? Squaring that, just square that. 0.7.
Oh, it's a negative, right?
No, it's going to be positive. If you square a negative, it's positive. 764. Okay, sounds about right. It should be positive because you're squaring it, right? Yeah, on the calculator, it's kind of funny. Any calculator really, but especially with these, if you don't, so watch, I'll show you. This is kind of a side note, tangent note, but look at this, watch. But look at this. What happened? Are they the same answer? Calculator's too good. It's too good sometimes. Sometimes when you put this guy up here, -2 squared, you're like, I just want it to -2 times -2, right? Well, the calculator knows PEMDAS. It knows order of operations. So when you put the top one in there, the calculator sees -1 times 2 squared. So it says, oh, okay, exponents times -1, it's -4. So if you want the calculator to do the negative number by on top of each other, like multiply itself, then you got to put parentheses around. And that's not true just of these calculators, it's true of all calculators. Like any little calculator, any calculator where that does exponents, if you put the negative sign in front without parentheses, it'll make it negative. And you're like, what? A negative times a negative makes a positive. You're right. But the calculator on the top one is not reading a negative times a negative. It's reading 2 squared times -1. Okay, so just be careful when you put the when you're putting stuff in the calculator. If you're not sure, put it in parentheses. If you're not sure, it'll always be okay with parentheses. Okay, so we got for this guy here, for R squared, for this guy, because we squared R, we got 0.764, right? So change that to a percent. What type of percentage? Yep, 76.4%. Okay. This is what R says in context of this question. 76.4% of the reason why the price is what it is because of the X, which is miles driven. It's a great example. It's a great question. What is the others? We don't know. Other factors. Well, what other factors could determine the price of a car? The car's been in accidents, it's going to hurt, right? Features. If it's a luxury edition, it's going to be worth more. If it's a standard edition, it's not going to be worth as much. How well you treated the car, right? If you're changing the oil every once in a while, you need to change the oil a few times a year at least, right? If you're taking care of it, those things. But what this says, what R squared says, is 76.4% of the reason why the price is what it is has to do directly with how many miles you've driven it. Okay, that's what that means. Okay, so let's look at another one. Let's see if we got another one here where we calculated R. We calculated R for R was 0.77 for this guy. So what do you get when you square that guy? What would R squared be here? What was it? 0.64? 604. All right, let me write that down. About 60%, right? Which converts to about a little over 60%. This data came from these guys here, right? 60% of the reason why their height is what it is directly related to their foot size. Okay. So less than the last one, right? So there's more variables. There's more bad English, but more other variables, right? This one's only 60%. So X is only 60% responsible for the height. There you go. Has directly to do with that. Yeah. Let's say we had a correlation that was perfectly strong positive. What would it be? One. Square one. What do you get? 100%, right? 1 or 100%. So that means that means there are no other factors that led to this. Okay, so it's an effect size. How much of an effect is X having on Y? Okay, let's look at another one. Is that the only one we have? Oh, here we go. Do I not have these numbers? We didn't calculate R. We skipped R squared. Yep, we're gonna do it today. Okay, so let's look at the numbers from yesterday that we were, no, not from yesterday. When are these numbers from? I found numbers in my calculator. They might be from there. Yeah, they are from there. They are from tell me if these numbers match the numbers in the ice cream question. Those numbers match the ice cream question. Okay, so let's calculate R squared for that. R, so just R and then R squared. So here we go. Pretty strong correlation there, right? 0.972, that's pretty strong. That's almost like perfect, right? So R squared is 0.972. No, sorry, 9445. That means 94.5%. 94.5% of the reason why ice cream sales are as high as they are, or as low as they are on some days, is directly due to the temperature. It's directly due to the temperature. It explains why ice cream sales are what they are, right? So there's not much other variability. There's like 5%, 5.5% other reasons why people buy. Maybe I just felt like having an ice cream that day. But most of the people, the reason why is because of the heat, okay? So R squared is, I like R squared because it's a lot of, if you tell me what R squared is between two things, it tells me how strong it is, right? Kind of like R, except it's a little more, you can use it a little more in context. So yeah, that's what R squared is. It's called an effect statistic. So how much effect? So here we go. Big, when I was in college, my statistics professor said there was a big study done, and what the study was, they wanted to determine what effect, because a big part of a big controversial subject in education, K-12 education, is school choice. School choice, meaning I should be able to send my student, I pay taxes, so I should be able to send my son or daughter to any school I want, whether I live in the district, whether I don't live in the district, or whether it's a private school or not, right? I should be able to use my tax dollars. So how it's worked out, how for every student, the school gets money. the district gets money, right? They're allocated money, anywhere between $10,000 and $14,000 a year for each student. So what school choice says is, I can take that money and take it with me. It's taxpayer money. I can take it with me and give it to a private school, and my kid can go there because there they'll succeed more. Okay. So like I said, I'm not offering one way or the other. It's just, that's, if you Google school choice, there will be literally tons of stuff. It's a very controversial subject within education. So a big study was done to see how much that matters. How much does the school that you're at matter? So that was the question. How much is the school you're at responsible for whether you succeed or whether you don't succeed? So Central, how much is Central, the school itself, responsible for your success or lack of success, or where you're at right now? Okay, so 100% would be Central does everything. The reason why you're here, if you were anywhere else, you wouldn't be where you're at right now. Either good or bad. That could be good or bad. Straight A student, straight F student. If the straight F student was anywhere else, they would be doing way better. If the straight A student was anywhere else, they'd be doing way worse. Okay? So what do you think the R squared was for that? So you think you have no, you think Central, the school,
Yes.
is everything, you're nothing?
Yes.
Okay,
Yes.
okay. 2%? 0.2% or 20%? 10%, okay. What do you guys think? 25%. What does anyone else think? What is the reason why, how you are what you are? So your success at school, most of you guys, I would say almost all of you guys, if not all of you guys, are successful. You have great GPAs. How much did Central, the school, have to do with that? So you said it's pretty strong. You know what the number was? The R squared. 7%. 7%. So there's a lot of other factors, 93% of other factors, right? It was the school you're at. So they looked at students from all over different schools in high school. 7%. That was the R square. That's not just no, that wasn't Central. That was school. They took thousands of students from all over the state, all over the universe, all over the, not the university, all over the country, just in the United States. No. That's a great question. I don't know exactly what they did, but they were able to get data, and like, I know it's pretty easy to quantify how successful you are. You can look at GPA. You can look at how many clubs you're involved in. You can look at how many sports you're involved in, how many extracurriculars you're involved in, whether you go to college or not, what happens afterwards, whether, it's pretty easy to quantify that. But how do you quantify other things? Yeah. So it's interesting. I've never read the research. I've just looked at what the results, and it's at 7%. 7%. What is probably the other 93% of the reason why you guys are successful as you are? Home life was the biggest one. Home life was the biggest one. Home life. If students have a stable home life where education is encouraged, that R squared is way up there. Okay. Exactly. Has to be both. Has to be where stable, meaning there's not a lot of movement. I mean, I have sad to say, I have a lot of students who are here for a few weeks, a month, and then they're gone because their life is really, not stable. So stability in your house, in your home life, and how much support there is for education. So encouragement, follow through, right? Those types of things. That was probably the highest. What was another one? There you go. Another one was a big motivation. How motivated you are. If you're motivated, you're going to do well. Okay, if you're not motivated, you're probably not going to do as well, right? Those things were the big ones. School that you're at had very little. So as much as I like to think I have a big influence on you guys, your guys' success, it really is the other things that you guys come in with. Okay. So when you guys take the AP test and you guys all do well, I enjoy it because I'm more happy for you guys, not for me, because I know about that 7%. That 7% is, as much as I would like to say, if it wasn't me in here, there'd be another statistics teacher in here going over the same type of thing, So I'm happy for you guys when you guys do well, but I understand that us here, the statistics say that it's only 7%.
Spalding was here.
Spalding?
Yeah, he's the one that accused them of cheating.
Oh, remember, this is being recorded, guys. So let's So anyway, I got you. I don't think the microphone caught you. I caught all the way over there. So yes, so that's what it is. That's what it is. So I like R squared. R squared is one of the more, because it's practical. It's how much did these guys have to do with this happening, right? 100% means it's everything. 0% means it's nothing. Anything in between means there was some to it. Okay, so that's R squared. Easy to calculate on the calculator, and that's how you define it. Okay, standard deviation. What's standard deviation? Don't worry about the residuals. What is standard deviation? How far, on average, how far are each of the data points away from the mean? Okay, good. Chapter 1, chapter 2 stuff, right? So all this is on average, how far are each of the residuals away from the mean? So if I calculated the mean, I have residuals here. We did a residual for the other day. Here you go. That's it. That's it. There you go. You got it, right? Here are all the numbers, right? Here are all the residuals, right? Negative big residual means I overestimated, right? Positive big means I underestimated, right? Above the regression line means I underestimated, because the regression line is the estimate, right? So if I found the average of these guys, on average, how far is each of them away from the mean? Okay, so if it's a big number, that means a lot of variation. If it's a small number, that means for the most part, they were pretty close to the prediction. Okay, that's that. Okay, so computer data output. Computer data output. Last thing. Hopefully we'll finish this. We should finish. The nice thing about computer data is they give you all the answers. All the answers are in there. We just got to kind of find them. Okay, so this is the example of what they did. So hand span. Hand span is the distance from the tip of a person's little finger to the tip of their thumb. So if you spread it as wide as you can, measuring from the tip of the thumb to the tip of the pinky, that's your hand span. Okay, so they measured that. Researchers gathered data in order to predict a person's left hand span using their right-handed span. Okay, so if you told me what this was, I could estimate what this is without measuring. Okay, you would imagine that they would be the same, right? They'd be very close or the same, right? Well, that's what they measured. That's what they said. Is it? Okay. So the scatter plot has a linear form. Okay, so that means the residual plot had no pattern. Okay. This is computer output of their findings. So we don't have to use computer output. We just have to be able to read it. Okay, so I'm going to teach you how to read it. Dependent variable. Dependent variable is left hand span. What's another word for dependent variable that we've been using? explanatory or the X, right? So this is the X or the explanatory. Good. There you go. And that's also here. It's right there, right span. It's the predictor, right? That's the thing we're trying to predict using left hand. So this is the response or the Y. Okay. Let's see. They're using researchers gather data in order to predict a person's left-hand span using the right. Oh yeah, you are right. So this would be the independent, right? Let's change that. Let's change that. So this should be the independent variable. Response, which is the Y.
Would it right be independent? The left depends on what the right.
That's it. The left be independent, right? There you go. There you go. Yes. It's Friday. Yes, dependent is X. No, wait. Independent is X. Independent is X because I can choose whatever I want and I plug it in and then whatever comes out is Y. Thank you. Thank you. Thank you. Yeah. So they did it right. I interpreted it wrong. Okay. Got that? Now we have a couple things on here that we're going to ignore. So I'm going to cross out some things. They're important and we'll talk about them probably second semester, but for right now we don't need it. See this P stuff right here? Cross it out. We don't need it. This T stuff over here, cross it out. We don't need it. We'll come back to that stuff second semester, but for right now we don't need it. Only focus on what we need. See where it says R squared down here, R square and R square adjusted? We don't want adjusted. We want the real thing. Yes, some of the times it will be the same number, some of the times it won't be the same number. In this one, it was still. But for the future, always just use regular R squared. Nowhere on there is R. Can I calculate R? What do I do? Square root, yeah. So we'll calculate that in a second. Okay, so I need a equation, right? I need an equation. So I need a slope and a y-intercept. So right arm span, right hand span is right here. So when I'm writing an equation, I'm going to write it in letters like y equals ax plus b, and then I'll replace everything and then I'll change it to in context. Okay, but I just want to get the numbers down first and then I'll do that. Okay. Actually, we could probably do this right now. What is x? What is the x? What is the independent variable? Right span. So it's going to be times right hand span. And then the y is left hand span, right? So predicted left hand span. Okay. So now I need a slope. I need a slope to multiply times right hand span. Okay. So the slope is in there. It's one of those decimals. We got 4 decimals there. We got this guy, this guy, this guy, and this guy. Well, this is the x right here, right? We said right hand span is the x, right? So a coefficient is right in front of a letter, right? So if this is the x, the coefficient of that is going to be that. So this guy right here is the coefficient of x, which in our case is the slope. Slope, so then slope. The y-intercept is a constant, right? Is a constant. It doesn't have, it's not in front of a letter. So you see constant right underneath. So the coefficient of the constant is the same number, is the same idea, but it doesn't have a letter in front of it. So that's why it's saying it's a coefficient of a constant, because it's kind of, the constant is just itself. So this guy right here is the y-intercept. Probably, I don't know. Yeah, just units. So probably inches. Let's just say inches. Was that, when is that? That's the y-intercept, right? So that means, when would I have 1.4365 inches? If I don't have a right hand. If I don't have a right hand, that's exactly, or if there's no distance between. Okay.
No risk.
All right. So now that we got that, so interpret what the slope is going to be. So how do I interpret it again? There's different ways to interpret, but pretty much what you want to say is
Something increase, decrease.
not that one, not zero, that's y-intercept. If we wanted to interpret that, we would say when like right hand span is 0, left hand span will be 1.4365. For every 1 inch of x, y will increase by that many inches. So for every 1 inch increase of right hand span, all right, that's x. Left hand span, that's y, will increase yeah, you can put predicted in there, will increase by inches. So for every 1 increase of x, what is y doing? That's the slope. Okay, so for every 1 inch of right hand span increase, how much is the left hand increasing as well? Pretty close to what? When we think that's for every time my right hand gets bigger, don't I think that my left hand will get the same size, right? Makes sense, right? Something close one, which that shows, right? It's proportional. It's not, we're talking about a 1/7 of a 100, a 1/7 of a 100th of an inch difference. So the data is showing that, yeah. So whatever data they have is showing that the right hand is a little bit bigger than the left hand. They're showing that the right hand is going to grow a little bit faster. Where is it? Oh, right here. What about it? Yeah, so let's see. when
your right hand is non-existent.
when your right hand is not existent, your left hand will be 1.4365. So yeah, starts out bigger. Yes, agreed.
Obviously, you know, right hand.
Okay. So yeah,
Yeah. All the excess goes into my left. It's gotta go somewhere, right?
so like I said, almost a 1-to-1 increase. 0.93 is 0.7 7/100ths of an inch. So if I had an inch here, here's an inch from the edge of this to my finger here is 1 inch. Chop that up to 100 pieces, 7 of them. That's nothing, right? That's very little, right? So pretty much 1-to-1. Okay, pretty much 1-to-1. All right, so last thing. Do that one on your own.
This looks like
Is it the same data?
This is the exact same data.
Okay, so do E, no, it's different questions though, different questions.
It is? Oh, it has D and F. Did we find it already? Did we? Did we not?
So do D and E, we'll do F together. Is it possible for R to be negative? It is, right? Look, let's look at our,
Left hand gets bigger, but your right one gets
I'm not talking about context, I'm just talking about in general. In general. In general. No, I'm not talking about in context. I'm just talking about, so like that brings me to my next question. How do we know? It is possible, right? From 0 to -1. Now, how do we know that we won't have a negative? Because if I square root a number, it could be positive or negative. If I find the square root of 0.9, right? Watch. So if I find the square root of 0.902, it could be a positive number, right? Couldn't it also be a negative number? For example, let me give you an easier example. Square root of 4. Could it be 2? Could it also be -2? Right? Same thing here with 0.902. So how do we know that it's always this one's going to be a positive? There you go. Because the slope is positive, it has to be increasing. The data was increasing. So this one, we're going to use the positive one. If our slope was negative, then R would be negative. Okay. So what was the square root of 0.902? 9473. 97. Okay, I don't want to round up. There you go. So very strong, positive, linear relationship.
That's what I said. I mean, S of E.
Okay, so R squared. R squared was 92%. So what do we say? 92%. 90.2. Sorry, yeah, 90.2. 90.2. In other words, the explanatory. So what was our explanatory here? Right hand length, or right hand span is 90.2% responsible for left-hand length, left-hand span. Okay. The last one is S of E. S of E is standard deviation. They don't, that's it right there. They don't use S of E a lot. They just use S. That's it right there. So S, anytime they give you computer data printout and it says S or S of E, that's standard deviation of the residuals. Okay, so that one's going to say 0.6386 on average. Each residual is 0.06386 inches away from the predicted. Okay. No, it's not a percent. Yeah. Standard deviation is just on average. I took all of those residuals, right? That list of residuals, I found the average. On average, how far are each of them away? So 0.6 inches, 0.6386 inches away on average. Some are wider than others. Some have big distances, some have small distances. If I found the standard deviation, or if I found the standard deviation, that's what it would be. Okay. And that's it. We are done with the notes. Perfect time. Next week, we're going to review a little bit, actually we're going to review a lot next week. And then probably a group test at least next week. I'm not sure if we'll have an individual test, but probably a group test next week. Sometime, probably Wednesday, Thursday, Friday, something like that. Okay.